Vegetation cover affects climate through its albedo, evapotranspiration, and surface roughness. The albedo ranges from 0.10 over forest over to 0.25 over grassland, hence causing greater absorbed solar radiation over forests. The evaporative response is shown to be very important in heat wave conditions. Tower measurements in Europe show that initially surface-sensible heating is 2 to 4 times higher over forest than over grassland, according to Tulin et al. Over grass, heating is suppressed by increased evaporation in response to increased solar radiation and temperature. Ultimately, however, this process increases soil moisture depletion in the grassland and induces a critical shift in the regional climate system that leads to increased heating. Because forests evaporate less water in the initial phase of heat wave, they can sustain a constant level of evapotranspiration over a long period of time than grassland. Surface roughness is a function of canopy height and plays a role in evaporation losses through its effects on the vertical gradient of wind speed. In general, greater roughness values lead to increased evaporation. Values of surface roughness length range from 0.04 meter for long grass to about 2 meters for tropical forests. Its value is approximately 1/10 the height of surface roughness elements. It represents the height at which the wind speed above the ground theoretically decreases to 0. Snow cover has major effects on climate, operating in at least 4 main ways. So, the first is albedo temperature feedback. This operates when snow cover shrinks, lowering the albedo from 0.08 to 0.9 to about 0.1 to 0.3. This reduction increases the absorption of incoming solar radiation at the surface by about 4 times on average. The warming of this surface leads to a further reduction of the snow cover, hence positive feedback. The effect works in reverse, with increased snow cover leading to enhanced cooling and a further extension of the snow cover. The second effect involves the insulation of the ground surface by snow cover. It cuts off the transfer of heat and moisture from the underlying surface to the atmosphere or vice versa, which modifies the thermal regime of the underlying ground and of the overlying atmosphere. Winter air temperatures in the presence of snow cover on the North American prairies are 5 to 10 degrees Celsius lower than with bare ground. The third effect is on the hydrological cycle caused by temporary storage of water in snow cover. This delays the annual runoff peak. The fourth effect involves the release of latent heat during the phase changes from vapor to liquid. The latent heat of evaporization is 2,500 kilometers per gram, and liquid to solid ice. The latent heat of fusion is 333 kilometers per kilograms, and that the corresponding heat inputs during evaporation and melt. Hence, evaporation requires nearly 8 times more energy than melt. Direct sublimation of snow to vapor requires 2,833 kilometers per gram. The sum of the latent heat of fusion and of evaporization, and thus is less common than snow melt. Ocean occupies 71% of the Earth's surface and consequently play a major role in global climate. Their large heat capacity means they heat up and cool down slowly. Ocean currents in the northern hemisphere transport heat northward in the North Atlantic and the North Pacific, keeping Western Europe and Southern Alaska respectively much warmer in winter than the corresponding latitudes in eastern North America and eastern Asia. Cold currents flow southward off East Greenland, Labrador, and northeastern Asia. A major part of the global thermal haline circulation and Atlantic meridional overturning circulation comprises the northward flow in the North Atlantic, with dense water sinking in high latitudes and returning southward at depth, much of it upwelling in the Southern Ocean off and Antarctica. The Arctic Ocean and adjacent seas are covered with 2 to 3 meters thick sea ice in winter. Ice extends to 40 degrees north of China. The ice shrinks greatly in summer and since 2005 has reached the lowest level of record in September. The ice has also thinned considerable and much less of it is now multilayer ice than was the case from 1979 to 2000. Large amounts of multilayer ice have been exported from Frame Strait via the transpolar drift stream. In the southern hemisphere, north-flowing cold currents affect the western coasts of Peru. The cold water turns westward in a narrow band along the equator. The broader Antarctica circumpolar current flows continuously around the Southern Ocean. In September, sea ice about 0.9 meter thick of Antarctica covers 20 million square kilometers, which shrinks to only 3 million square kilometers in March. In the southern hemisphere, there are 3 atmospheric convergence zones that extend southeastward from continental heat lows. The southern Pacific Convergence Zone is unique in having both tropical and extratropical components. In the eastern subtropical oceans, a major feature is the presence of extensive marine stratocumulus. Downstream is the trade winds. Cloud cover eventually breaks up. In the Caribbean and in the western North Pacific, there are wave systems traveling eastward between April and November. About 10% developed into tropical storms or cyclones. In the subpolar oceans of both hemispheres, mesoscale polar lows traveling eastward are an important element of weather and climate, bringing severe weather conditions. Tropical storms and cyclones form from pre-existing waves or depressions in low latitudes and travel slowly eastwards. They form in all tropical oceans except the South Atlantic. They are most frequent in the northwestern Pacific, the South Indian Ocean, and the northeastern Pacific. Cyclones have inward spiraling cloud bands, very strong winds, and an internal eye 50 to 100 kilometers wide, where winds are light. Many recurve over the western oceans into the mid-latitude westerlies and may reform as an extratropical low-pressure system. Over land, the annual temperature range increases greatly away from windward coasts. Maximum continentality is in the northeast Siberia and the Yukon. The precipitation amounts decreases inland away from windward coasts, especially in the lee of mountain ranges where there is rain shadow. Mountain summits and Windward slopes may receive 4 times the annual total windward. Vegetation covers affects climate via its albedo and surface roughness. Forests can sustain high evapotranspiration rates much longer than grassland. The climatic influence of snow cover operates via albedo temperature feedback, surface insulation, water storage, and phase change effects on latent heat.